Lately, we see plenty of games failing to meet the expectations of developers, publishers, and players. I often see the blame targeted at developers, as if they intentionally delivered a subpar product. I've been in the industry for almost 20 years, starting as a developer, moving to graphics development, and spending the past years as an engineering manager. Let me tell you, if you are dissatisfied with a final product, your rage aimed at the developers is misdirected. Let's talk about how software is actually made. Universities don't always teach the realities of software development well. Programming itself, you are covered. But methodologies, it usually sounds like boring theory because you can't emulate a full-scale development cycle spanning hundreds of people across multiple countries. You've probably seen that classic waterfall diagram, making software creation look like a perfectly clean, predictable staircase. That diagram is obsolete at best and literally misleading at worst. There might be a very few specific exceptions where full-scale waterfall makes sense, but this is not our case. In the real world, the software development lifecycle isn't about drawing charts to keep management happy or memorizing all the steps. It's a survival guide. It's the only thing standing between your team and an unmaintainable mess, or worse, a product you can't sell because there's no audience. Today, we are going to strip away the corporate buzzwords and academic fluff and look at how software is actually built, from blank text file to a shipped product. Let's look at phase 1, planning and feasibility, also known as the reality check. Before writing a single line of code, you must ask two brutal questions. Should we build this? And can we actually build this? This is a team effort. The product manager, PM, drives the should we build this part, figuring out if users actually want the feature and if it makes business sense. Then, as an engineering manager, my job is to step in and look at the cold, hard facts through a resource assessment. How much time do we have? Is the deadline flexible? What's the budget? Crucially, do we have the right skills? If you ask a team of backend web developers to suddenly build a custom 3D rendering engine, you are going to have a bad time. This brings us to the technical feasibility, which falls on your tech leads or senior developers. They must decide right now if the hardware or current tech stack can even support the PM's vision. For example, you can't run ultra-complex physics with tens of thousands colliding objects on a 10-year-old budget phone. Tech leads need to identify these roadblocks upfront. If you skip this reality check, you risk burning through 6 months of budget and your developer's sanity, only to realize the project was doomed from day one. Welcome to phase 2, requirements analysis, or translating human into logic. There's a massive misconception that once a project is approved, developers just crack their knuckles and immediately start typing code. But there is a problem we face. If you perfectly build the wrong thing in C++ or Python, it's still the wrong thing. This phase is all about figuring out exactly what that thing is. Usually, a product manager or business analyst brings stakeholder requests to the engineering team. The problem? Well, stakeholders don't speak computer. They speak in vague, emotional terms like make the app pop or make it feel fast. As an engineering manager working with tech leads, your job is to translate those feelings into actionable, measurable technical requirements. Make it feel fast means nothing to a compiler. You and your senior developers must turn that into concrete goals, like 60 frames per second rendering, API response times under 200 milliseconds, optimized spatial partitioning. This is where you lay the tracks before the train starts moving, ensuring that when the team finally writes code, they are building exactly what the business needs, not just what they guessed it wanted. Now we arrive at phase 3, system design and architecture, which is essentially drawing up the blueprint. And yes, you still don't get to code. Jumping straight into your IDE right now is a massive trap. It's exactly how you end up with unmaintainable mountain of spaghetti code 6 months down the line. This phase is the playground for software architects and senior developers. As an engineering manager, I review the plans to ensure they align with our timeline and budget and give the final sign-off, but the actual structural design is built by the technical veterans. This is where the real engineering happens: the math, structural logic, and heavy system architecture. Your architects must make the foundational decisions to choose the exact right systems for the job. The very important rule here: think about data. Before a single line of application logic is written, database administrators and backend engineers are designing schemas, core data structures, and class hierarchies. They define the system's limitations upfront. If you don't get your data model and architecture right at this stage, no amount of clever coding will save your product from collapsing under its own weight. Phase 4. Implementation and coding. When people picture software development, this is what they see. But in reality, coding is just a fraction of the entire life cycle. Now, your software engineers, from juniors to seniors, finally get their hands dirty writing the application. Meanwhile, my role as an engineering manager shifts to clearing roadblocks, protecting my team from not always important meetings, and ensuring everyone sticks to the blueprint from phase 3. This is also where your technical program manager, TPM, steps in as an air traffic controller. While we build, the TPM tracks project velocity and ensures that if we are waiting on a piece of code or an API from another department, it actually gets delivered on time. Let me stop here for a moment. Notice how far we've come before developers actually started writing code. We are way beyond deciding what to build, how it works, or what the user experience and features will be. While senior developers were involved in earlier phases, the final decisions and green lights simply aren't in their hands. Phase 5. Testing and integration. Actively trying to break your own code. This is where we face a hard truth. Your code will break. Many junior developers think that if their code simply compiles and runs locally on their machine, they are finished. This phase requires a major mindset shift and brings in crucial new roles. While software engineers write their own foundational tests, quality assurance, QA or QE, take the spotlight. Their entire job is to systematically tear down what the developers just built. As an engineering manager, my role is to defend the schedule to ensure we don't rush this phase just to hit an arbitrary deadline. Shipping broken software to angry users is infinitely worse than delaying a launch, which should be obvious, despite what shareholders might think. Once the individual pieces are sorted, we move to integration, plugging all the isolated components together. QA runs integration tests to ensure the database talks to the backend, and the backend hands the right data to the user interface without the whole system catching fire. We are here at phase 6, deployment, the moment of truth. This is where your project finally breaks out of the sandbox. Everything that runs safely in local environments or controlled testing servers must now be pushed live to production servers or public app stores. This phase is ruled by DevOps engineers, and this is often where your TPM wears the head of release manager. They organize the go, no-go launch meetings and coordinate the massive deployment effort across multiple departments. As an engineering manager, my blood pressure usually spikes here. My job is to coordinate the launch window, notify business stakeholders, and even ensure we have a crystal clear rollback plan in case things go completely sideways. Modern deployments rely heavily on automated continuous integration and continuous deployment, pipelines built by your DevOps team. This ensures we never have to manually drag and drop files onto a live server via FTP like it's 2005. And then comes the actual go live moment, bringing a very specific type of adrenaline. You transition entirely from building the software to intensely monitoring it. This is where site reliability engineers, SREs, step up. They watch massive dashboards tracking server loads, database latency, memory usage, and real-time error logs. You just hold your breath, watch the metrics, and get ready for the final phase. Phase 7. Maintenance and operations. People like to think of software as a building. Once the keys are handed over, the project is done. But software is more like a living organism or demanding garden. If you don't actively maintain it, it suffers from code rot. Operating systems update, third-party APIs change their rules, and the new security vulnerabilities emerge constantly. This phase is a massive team effort involving almost every role we've discussed. Your SREs and DevOps teams constantly monitor the infrastructure to keep servers online. Customer support and community managers are on the front lines, fielding angry tickets and filtering complaints back to the PMs, who then decide which bugs are critical enough to interrupt the engineering team. As an engineering manager, my hardest job here is a constant negotiating how much time developers spend building exciting new features versus fixing the old stuff. Here's the biggest open secret in tech industry. Maintenance is where the vast majority of projects' lifespan and budget are actually spent. You might spend 6 months building version 1 of an application, but your team will spend the next 10 years maintaining it. So now that we walk through all 7 phases, I have a confession. It's not always like that, and it is not that straightforward. By explaining the phases in a numbered list, I made it sound exactly like that waterfall diagram from the beginning. Let's fix that and talk about the iterative reality, Agile. In the real world, modern teams almost never walk in a straight line from planning to deployment. That's a recipe for building a massive product nobody wants by the time it launches. Instead, we compress those 7 phases into small, rapid loops. We take one tiny chunk of the project, like getting a character to move or building a login page, and we plan, design, code, test, and sometimes deploy that specific piece in a matter of weeks. Then we start the loop over for the next feature. From an engineering manager's perspective, this iterative cycle is essential for survival. Breaking a massive project into continuous loops is how we manage the insane complexity of modern software. It allows us to adapt when the PM changes their mind, or when stakeholders see a working prototype and realize the feature they ask isn't what they actually need. Crucially, it's also how we avoid burning out our developers. Giving the team a steady stream of small manageable victories keeps morale high, rather than forcing everyone to start down a monolithic 2-year-long project. To wrap all of this up, you have to remember that the software development lifecycle isn't some rigid set of holy commandments designed by management to make your life miserable. It is simply a practical framework meant to manage the chaos. It handles the organizational and structural complexity so the team, you and your team, can actually focus your energy on what you love doing, solving the fun, hard technical problems. A quick disclaimer. In indie studios, smaller teams, one person might wear 3 or 4 of the hats we discussed, but the phases remain the same. I hope you learned something new today and maybe understood a little better how software, including your games, is made. Don't be angry at developers. Don't be angry at all. But if you need to, management is here to blame. The people in a very different pay grade than your poor developer doing what is planned, following specifications. If you want to talk, join our Discord server. If you would like to dig deeper into, say, software development to join our ranks, watch this video where I'm sharing some common traps you might fall into. And as always, if you like what you saw and want to see more in the future, hit the subscribe button. Ciao!